Okay, problem number 3. Find the center, foci, and vertices. That's all I have, sorry, of the ellipse. 4y squared minus 24y, blah, 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 and do everything else as well. So, what do we need to do to this equation right here? Well, we need to complete the square, not once, but twice, on x and on y. So, how do we do that? Well, I'm going to do a couple things to start. First, I'm going to factor out the leading coefficient of each variable. So I'm going to factor out the 4 from that y squared. So I'm going to be left with a y squared. I'm going to factor that 4 out of the negative 24 as well. So if I take negative 24 and divide it by 4, I get negative 6. So that's how many y I have. Then I'm going to do the same thing with my x term. I'm going to factor out that 9 to be left with an x squared plus 36 divided by 9 is 4x. And then that plus 36 I am going to subtract over to the other side. So there we have that. That's a pretty good start. Now let's go ahead and complete the square. So to do so, I'm going to leave that 4 as it is, and I am going to complete the square. And I'm not going to show all my steps because honestly I think it's almost easier to not. And I'm not teaching you how to complete the square here. We are using completing the square, something we learned long ago. So I'm going to complete that square by taking y minus 3 and squaring it. Where'd that 3 come from? Well, it's half of that negative 6. Okay, I will balance the equation in a moment. First, I'm going to complete the square on my x term as well. So notice that since I'm adding things to this side of the equation by completing the square, I need to make sure I add those things as well on the other side of the equation. That's how I complete the square anyway. You could also do it other ways, but I think this is the most efficient if I would stop blibbering and blabbering. So let's complete the square on x by writing x plus 2 quantity squared. And now we can say equals my minus 36, but let's balance this equation. What did we add to our y expression there to complete the square? Well, we added this term. Whoa. We added this term 3, but we squared it, which means we really added 3 squared, which is 9. Wait, but Mr. Reed, there's a minus in front of it. Well, negative 3 quantity squared is 9 as well. So we added 9 to the inside of those parentheses, which means we need to multiply that by 4 as well. So really we added 9 times 4, 3 squared times 4. So I need to add that to this side over here. Well, what is 3 squared times 4? 3 squared is 9, 9 times 4 is 36. So I added 36. Hey look, I got a minus 36 and a plus 36. Let's go ahead and cancel those out right now. So currently this right hand side is equal to 0, but I'm not done balancing yet. I still have my x completed square, which, how much did I add there? Well, I added 2 squared is 4 times 9. Look, I also added 36. That is nutso and a coincidence based off of the numbers that I chose. It won't always be that way, but I added another 36 to the left, so I added another 36 to the right, which means I end up with just 36 on the right, because I had a negative 36 and 2 positive 36. So there you have that. Alright, well, what do I do now? This does not look like an ellipse. What's the dealio? Well, that's because the right side of the equation says 36, not 1. So how do we get 36 to become a 1? Well, we could subtract 35, and that would then mean we need to subtract 35 on the left. So then it would no longer be in our factored ellipse form. So that's a problem. So let's divide by 36. But if we do it there, we have to do it to every single term, and so I'm dividing everything by 36, and now I can simplify. What is 4 divided by 36? I don't know, that's a fraction, that's gross. Well, how about you do 36 divided by 4, and acknowledge that 36 divided by 4 is 9, but we wanted the reciprocal of that, so we need 1/9, which means we get a 9 in the bottom, and so we have y minus 3 quantity squared over 9. Plus, what's 9 divided by 36? Well, again, I don't know, but what's 36 divided by 9? 36 divided by 9 is 4, which means the reciprocal of that is 1/4. And so I have x plus 2 quantity squared over 4 equals 36 over 36 is 1. And so, what do I know from this? Well, I know a couple things. I know my center is the point -2, comma, positive 3. That's kind of cool. What else do I know? I know that a is equal to 3, the square root of 9, the square root of the larger denominator, which means that b is the square root of the smaller denominator, 2, which means that I could also find c, which is going to be, remember for an ellipse, we have the relationship a squared equals b squared plus c squared, so a squared equals c squared plus b squared. What do we not know? We don't know c. So we can say a squared minus b squared equals c squared, but let's go ahead and square root that to figure out what c is. And so we can say that we have 9 minus 4. Notice what I did there. I took 3 and squared it to get 9. I took 2 and squared it to get 4. Oh, look, those are also my denominators. Okay. Well, 9 minus 4, square root of that equals c, which means c is the square root of 5. Again, that number pops up a lot based off of the simplicit beauty? What am I trying to say? I don't know. I think I just made up a fake word. I said simplicit. That's not even a real thing. I was going to say simplicity, but I don't know. Maybe simplicit is a word and I just haven't checked a dictionary. I don't know. Anyways, it was simplicit. Okay, well, what can we do now? Well, I know A, B, C, and my center, which means I can find a lot of different pieces. I can find my vertices. I know my vertices are first off going to be in line vertically because the larger denominator is with y, which means this is going to be a vertical ellipse up and down, which means the y value of my center will change, the x value will remain the same, -2, comma, then I'll have 3 plus or minus my a value, which is also 3. And so I'm going to have a vertex at -2, comma, 6, and I'm going to have a second vertex at -2, comma, 0. What about my co-vertices? Well, my co-vertices will again occur out from the center, but this time horizontally along the minor axis. How far out will they be? Well, they will be out B, haha, which is 2. But notice now this will be horizontal, and so my x value will change. So it will be -2 plus or minus my b value, which is 2, comma, the y value of the center, which was 3, which means I have a co-vertex at the point -2 minus 2, which is -4, comma, y value is 3. And I have a second co-vertex at the point -2 plus 2, which is 0, comma, the same y value, 3. Last thing we should find, how about the foci? Well, my c value is the square root of 5, which means I'm going to write my foci as, first off, they have to be up and down because our major axis is vertical. So I'm going to take the x value of the center. That's going to remain the same since they're in line up and down. And I'm going to change the y value, which was 3, but I will add and subtract the square root of 5. There you have my foci, my co-vertices, and my vertices. What else should we do with this? With this information here, let's go ahead and find our eccentricity. Remember, we just did it 3 times, basically. 2 times, maybe. This is the third problem. C over A. So it's going to be the square root of 5 over 3. And I'm not going to calculate a decimal right now because I don't have my calculator out and I don't want to mess with that. So there you have that. What else should we do? Well, we should write this equation in parametric form. So let's write that as x equals 2 times the cosine of theta minus 2. The first 2 came from the square root of 4, the thing underneath the x. The minus 2 came from the plus 2 in the parentheses. All right, well, what about y? Y equals 3 times the, not cos, whoops, how about the sine of theta plus 3? Boy, if I was teaching you this for the first time, I couldn't have picked a worse example because 2, 2 and 3, 3. Well, that first 3 came from the 9. It was the square root of 9, our a value. The second 3 came from that minus 3 on the inside. It is our k value. So there you have that parameterization. And I don't even know, is there anything else we should do? I mean, we can go through and take the derivative, but I don't really want to do that right now. So I guess we need to graph it. Okay, well, that shouldn't be too hard for us. We know a lot about this little ellipse. Well, what do we know? Well, we know everything, but I'm just going to graph it as if I didn't find all those points, because honestly, for me, that is easier. So x value of the center is -2, so 1, 2, y value is 3, 1, 2, 3. Boom, there's my center. The 2 with the x says go to in both directions x-wise. Whoa, that was weird. Didn't mean to do that. Just go ahead and ignore that big line. There you go. Okay, and the 3 in front of the sign with the y is saying from that center go up 3, boom, and go down 3, boom. So there you have our ellipse. That was pretty straightforward.